2023 to 2032. And the difference that innovation can make in influencing that growth trajectory is going to be the difference of whether we can actually overcome that hump. Now, this is the theory of change that the minister talked about in terms of how are programs influencing and supporting innovation and growth in the sector. And like I said, if we are looking at increasing growth, etc., and looking at decision support systems to support farmers, modernizing the sector, using the latest technologies, it's going to be, none of these things are actually new. It's about how and which approaches we're going to be using. Hence, public-private partnerships become really key. Of course, if you're here, you also know that plant health, animal health, a lot of these diseases influence productivity of the sector. And to minimize the losses, we have to have efficient systems in terms of how we manage these pests and diseases, how we have integrated systems to actually overcome these. And this needs to be done in such a manner that we develop the necessary capacity. We put in systems that actually harmonize the work that different stakeholders do in the sector. So the National Biosecurity Hub was launched on the 11th of October 2022 by the two ministers. And during that time, they also released an e-journal which really looked at biosecurity and renewed focus. We can share the link to that e-journal. And of course, the issue is, how is the Biosecurity Hub set up? And it's set up in such a way that we can fund public-private partnerships that collectively in plant health or animal health can contribute to the goal of securing our biosecurity, of securing biosecurity spaces such that we are able to have systems, both sanitary and phytosanitary systems, to support domestic and international trade. With that, I'm going to stop there and hand over to Mr. Rudolf Nieuwenhuis. You can go to the next president. I'd like to welcome Mr. Rudolf Nieuwenhuis to the floor to share with you the work done in CropWatch Africa. Thanks.
Good morning, everyone. Thank you for joining this session, and thank you, Maneshri, for the introduction. As mentioned, my name is Rudolf Nieuwenhuis. I'm from CropWatch Africa, and I'm just going to go through who we are and some of our services, and then mostly focus on the work that we do within South Africa. So I'm not going to go through that whole introduction again. It's the same as Maneshri said. I must just mention that that character there is not a selfie that I took and posted on my slides. That guy is actually called Vin Weisef. He's our awareness character. He's made out of bugs and flies and all that, courtesy from the USDA. And in the sectors that we operate in, we first started within crops, hence the name CropWatch Africa, about 10 years ago. But since then, we also moved into forestry, wildlife as well, and now we are busy rolling out livestock, aquatic, and then also ports, especially the ports of entry for monitoring there. So our core services, we mostly do early warning surveillance, area-wide surveillance, delimiting surveys, on-farm surveys. So anywhere where any survey needs to take place, that's where we fill the gap. So we look at anything new coming into a specific country or region. Once it comes into that area, we monitor to determine the spread. We also do risk assessment surveys for pest and disease status surveys. So if an industry or a government needs to know if the pest or disease is present within a certain area, maybe the country or the commodity wants to export products, and we don't know what the status of the pest or disease is that's affecting it, we go in and we do the surveys there. And we go cross borders, so we're not only looking at South Africa, we're also looking at our neighboring countries and beyond. And then a lot of focus is on community and on-farm training, and then capacity building training, risk analysis, damage assessments, etc. So as Maneshi said, we developed our own cloud platform called Biosecurity Africa, and this came in 2017 when fall armyworm came into the country. We had a system called CropWatch, which was working fine, but the FAO asked us, but can we do something for the region? And that's when we launched Biosecurity Africa, so that governments can have a platform to use with data that's been collected across multiple sectors to see exactly what's happening in their respective countries. So we simplified it with a mobile app that you can collect data in the field. You just basically fill out a form. It can work in online, offline mode, and you have a map, and the inspectors or the guys working in the field have images that they can verify what they see in the field compared to what's on the app. They make a selection, and you can generate all your reports right there in the field from the app to share with the farmer or to share with the community. We went one step further. We also developed a sightings app which is freely available to download throughout the whole of Southern Africa, and that is directly linked to the respective NPPOs within the countries. So if you're a researcher or public user or government official or industry partner, you can register, download the app, register for free. If you come across an unknown pest, unknown disease or migratory, you can actually just log a sighting, fill out a form, you can take a video, you can take a voice note, you can take images, and you can also set up notifications for yourself if you want to see for specific areas within your region, is there a new pest or something reported, so that you can have that information, but most importantly, that governments and industries can use this information that comes directly from the field, so that they can make informed decisions. So biosecurity and monitoring, we need to monitor for pests and pathogens, their spread. We are looking at new technologies where we incorporate weather data directly with the trap, so you can start correlating that information using remote sensing with the surveillance, or either making use of drones or satellite imagery, either of a specific farm or over larger areas, and then start doing change detection over time to see what the effects are. And then all the data, it's nice to collect all the data and have all the data, but you need to make informed decisions from the data that you receive. Different pests and pathogens, where are they active, what their current spread is, etc. So this is all nice that we can have all this data and collect all the data and make it available, but we are one of a couple within, say, Southern Africa that does this type of work. So we've got data, other people has got data. There's a lot of companies that does precision farming that sits with data. If you look at the Syngentas and the John Deeres and stuff, they sit with a lot of data. And I think this is exactly when or why the Biosecurity Hub and the Information Hub was established is to take all these data sets that's scattered all over the place and bring them together into one centralized place. And the Department of Science Innovation is the driver and the funder behind the Information Hub. So just briefly, how it all fits together is under Innovation Africa, we've got the National Biosecurity Hub, and their role is to coordinate with different role players, industries and government on projects. They get all the funding together and coordinate the efforts for surveillance, for pest and disease listings, and also assist Department of Agriculture with interns to fill the gaps that's needed there. So our role in the Biosecurity Hub is purely the surveillance. So we would conduct surveillances either for industry or for government itself. And the data that we collect is culture, so they are the gatekeepers of the data. So we can't go out in the field and monitor for a new fruit fly, and we say, oh, we've got a new fruit fly, and the information goes directly to the Information Hub, and it's public in the public domain. So government is the gatekeeper for all the information that goes into the Information Hub. They verify it, and then they release it to the Information Hub. And from the Information Hub, there is different levels where you can access data. So researchers has got areas where they can access data that's been gathered throughout the country. Government has got access to data. So it all comes nicely together. And then from our part, we work closely with different research institutes. We do a lot of sentinel plots where we deliberately plant, for example, maize to find out, and we do not spray any chemicals because we want to track as much as pests and pathogens as possible so that we can do those collections and then provide it through to the research organizations. Work closely with the ARC, and I think that came from 2016 where we first intercepted Tuta absoluta in the country. And it was within the Kruger National Park, a place where you don't expect agricultural pests, but that's where we first intercepted it. And also with international organizations, the USDA, the FAO, and quite recently the UK government within the region. So with the Information Hub, everything comes together, your remote sensing, your data, all the training, all the disease management, everything into one centralized place for decision making. And just to recap, integration makes the tools useful. So all the data that we collect on our own system with all our own maps and nice graphs and stuff, that goes through to the Information Hub. And in the Information Hub, this is an example of a grain survey that we did with Grain SA and Fabi, where we surveyed for 3 different grain in 7 provinces. So that information is available on the Information Hub, and researchers can take that information, couple that with weather data, and start making informed decisions or inform industry on best practices going forward. Thank you very much.
Thank you very much, Rudolph. Next, we have Dr. Ansa van Vieren, who will give us her presentation. Ansa, over to you.
Thank you. Oops. Good afternoon, colleagues. I realize that I stand between you and food security, so I'm going to try and make it as brief and as short as possible. Can I have the first slide, please? Oh, should I wait? Okay. So you've listened to Maneshri's introduction on how this biosecurity hub works and the participants, and then Rudolf gave a very in-depth discussion about CropWatch and their responsibilities and their contribution to the biosecurity hub. So we're going to take a little bit of a step back and zoom in on a particular aspect of the biosecurity hub, so plant health in particular, and then we're going to zoom in a little bit more and say, what is it that the Agricultural Research Council has that is unique, that contributes to this initiative, this wonderful initiative? And yeah, it's really without DSI we wouldn't have had that. So it's a massive initiative for the mandated arm for research from DELROD, which is the Department of Agricultural Land Reform and Rural Development. So briefly, we take our marching orders from them. But what makes us unique is that we are also the custodians of the national collections. So the national collections is pretty much, for the layman, a foreign concept and not something that everyone understands very well. But it's basically a repository of living and preserved collections that the ARC hold on behalf of the people of South Africa. So everyone that pays tax, which I assume is everyone in the room and everyone else, owns this. The ARC are basically just like a library, and the books in there belong to all of you, the people of South Africa. So why is it important? So the national collections are used fundamentally in the pursuit of biosecurity and particularly of plant health. Many of these collections, the living ones and the preserved ones, are type specimens. So you heard Rudolf mention the tuta for the first time. So a type specimen is the original name-bearing specimen, and we hold those. So in other words, the very first time a tuta was described in the world, in South Africa, that specimen is in the collections. And so when a new pest or a disease is identified in South Africa, those type specimens are used to confirm the identity. So briefly, the biosystematics, which is the building that you saw on the very first slide, holds more than 3 million specimens, and that's just the microorganisms. So then you have the gene banks, the living collections, the natural science collections, the data banks, and the facilities that are very unique to the IRC. So this is just a, oh, sorry for that lighting, but this is just a summary to give you an idea of what is held in that building. It's accessible to everyone, it's available to everyone, so anyone in South Africa that wants to do research, wants to look at it, wants to use it, it is accessible for them, of which the insect collection is the largest, and understandably so, because that's where our pests and diseases are coming from. So just to recap what has hit South Africa in recent years, you heard about fall armyworm that came in 2017, Tuta absoluta in 2016, the banana bunchy top virus, American foulbrood, which is a devastating disease for our honeybees in South Africa, and some other diseases there. And then we often forget about the invasive alien plants that threaten our natural resources. And what are the ones that we are keeping a lookout for, and that we are involved with public-private partnerships, with surveillance, with looking for both the vector and the pathogen? That is the Asian greening disease on citrus. As you know, citrus, South Africa is a huge exporter of citrus, I think only second to Spain. And so the crop really contributes to the GDP, so we're looking for both the pathogen and the vector that needs to be in combination in South Africa. So we already have the Africanus strain, and we have one of the vectors, but not the other one, and maize lethal necrosis disease. We also, a lot of vectors are involved, but the pathogen as well, and we know that the pathogen is currently in Tanzania. So this is the kind of information that influences our activities under the guidance of DELROD. And it doesn't want to move. Oh, there it works. So when we talk about the importance of public-private partnerships, so a lot of what Rudolf has spoken about is where there is collective efforts around a specific disease or a objective of a project. But what we often forget about is the alien invasive plants. So the ARC is very active on on developing biocontrol management strategies for these plants that threaten our natural resources, of which water is the most important. So where the relationship with private entities or public landowners really become important is because these are long-term projects. So once a biocontrol agent is identified through a survey and through host-specificity tests are released, on a particular site, it becomes a long-term monitoring site. So often, because land exchanges hands, or there are veld fires, or people just clear bush encroachment because they become impatient with the speed at which biocontrol work, we lose these long-term monitoring sites. And it becomes data gaps, which is really important for us to explain and demonstrate the efficacy of the work that we do. It's really important to have a common understanding and awareness from landowners around these projects. So just going back to, we spoke about Tuta absoluta and the Asian greening and the banana bunchy top. The complexity of these diseases is the fact that they both have vectors and the disease itself, and that they have to be in combination with each other. And just to give you an idea of when you think it's important or easy to identify these pests, it is not. You really need the taxonomic expertise. As much as molecular work has evolved, the morphological taxonomy still remains the backbone of the accurate identification, followed up by the molecular work. So that's why these type specimens and the national collections are so important, because they provide that morphological backbone that you need before you can start with the molecular work and the innovation. Just to show you how difficult it is when you look at the vectors of Asian greening, how closely related they are, and why it's really important to have the expertise to identify those. So what happens when, like in 2017, when the fall armyworm was identified for the first time? So the fall armyworm specimen that was used to identify the sample that was submitted was actually 100 years old. So that was used, the morphological identification was based on that, and then obviously after that, molecular confirmation followed. But that basically triggered the emergency response plan, which is a result of the and we go to rural communities, and through those interaction, as much as we have the formal sort of monitoring and surveillance, we also have this kind, which sometimes bring a lot of valuable data to the fore in terms of new arrivals in the country. Then I spoke about our diagnostic capacity, the importance of having that morphological backbone and the molecular work that comes later, as well as having the accredited facilities and the quarantine testing facilities for when you bring in new biocontrol agents. And then our research focus areas, like I say, is very much governed by what is needed in the country. So examples, for instance, is that the ARC is leading a big, under the Biosecurity Hub and as part of the Dalrod service level agreement that we have with them, a survey on maize lethal necrosis disease to say, we're looking for associated host plants as well as the vectors along the major trade routes and transport routes. And the importance of this is you can't do a survey only once. So if you've done one 5 years ago, then you kind of have these gaps in the information, and you need to have a continuum in terms of the information that you gather around this so that you're continuously aware. And then also, for instance, on the Asian greening, we are part of the steering committee, which is made up from the commodity organizations, where very regular meetings are held to say, what should we do in terms of what is happening in the neighboring countries, and should we be expanding our delimiting surveys, etc., etc. So that's how we play a role there. I spoke about the emergency response plan. This was what happened after fall armyworm. A lot of fact sheets were produced, translated into local languages, and a lot of information was shared. And then subsequent to that, that would influence the research proposals that would come to say, where is the fall armyworm overwintering? Let's look at the molecular information and harmonize the techniques for identification so that we can see what are the strains that are available in South Africa. And just when we spoke about innovation, I think everyone could have heard about the locust outbreak. So we have regular locust outbreaks in South Africa. And it's very interesting. So when Rudolf said, and he mentioned his app, and he said people can, when they have a sighting, record it on the app. Locust is actually, by law, you have to report it. So when you have a locust outbreak on your farm, you have to report it by law. So the innovation around that and the challenge with that is that in the Karoo, because of climate change, we've had a lot of, I don't want to say abandonment of farms, but sort of a depopulation, especially in the central Karoo basin and more to the northern areas. So what that causes is you have gaps again in your information where people are not there to report the outbreak of the hopper bands. So once we have that report, then the locust control officers can go and manage the hopper bands on the ground before they establish and expand. So that's why it's so important that we work together but also innovate here. And so one of the projects that we are doing under the Biosecurity Hub is to digitize more than half a century worth of data on outbreaks of locust so that it can be used to predict with better accuracy when the next outbreaks would be, so that we can use the resources that we have to control the hopper bands in the areas before they become established and bigger. And that's all from me. Thank you.
Thank you very much, Dr. Ansa. So with that, the floor is open for questions. We have, well, not a lot of time because we started a bit late, but perhaps if we can spend about 10 minutes, I think that would be good. Questions, comments? I don't see any hands. I'm standing between them. We're standing between them and lunch. So maybe I can ask the first question, because I think a lot of the audience perhaps also are not aware of some of the work we do on capacity building and training. So perhaps I can ask the first question. So perhaps both yourselves, how important is capacity building and training in terms of the pest risk analysis, as well as training the necessary phytosanitary pathologists, if you can call them, that are necessary to support the hub? Maybe we can start with yourself, Ansa, and then Rudolf.
Thank you. Is it on? Is it on? Okay, so that's a really valid question, and it's a bit loaded, because the interesting part about it is that in the ARC, we are often arranged according to disciplines or areas. So in other words, either a crop or a pest, whereas what you are referring to is an application. So the challenge there is that we actually don't train people necessarily in the end result, but in the basic that is required to do that. So it's very important, especially when we when we think about the taxonomic expertise that is required for some of these pests and diseases, like mites, for instance, there's a lot of scarce skills around mites. So what the ARC do have is a professional development program that we use to identify and train people up in these areas. The link between when somebody is trained up and how to apply the craft that they have learned, I think that's where the challenge is. And I think that's where an initiative like the Biosecurity Hub can play a big role by bringing those together, like Rudolf also said, is to say, yes, so-and-so have been trained in this particular area, but now can they work in this environment to enrich, for instance, the pest risk analysis?
Thanks very much, Ansa. Rudolf?
I think just to add to what Ansa said now, I think it's important that the people who does the work, let's take the pest risk analysis, for example, knows what happens in the field, what is out there, what do they need to do, because most often the guys are sitting in the office and they've got all the paperwork and they know they need to do point 1 to 10, they need to fill it out, they need to get the information. And that's where the Biosecurity Hub plays the role, is to take those people out in the field and make them aware of where does the information come from, why do they see what they see, and why do they need to collect the information. But I think there's currently interns at Dalrad who's going through this process, who's assisting Dalrad with this.
Thanks very much. Still no questions? So the second one I want to highlight, and then the issue of how we bring and share this information, because it's one thing to do the characterization, do the morphology, do the molecular biology, and then do the monitoring. How do we then share this information and make it accessible to farmers? Rudolf talked to some aspects, but perhaps you can talk to also the work done with the farmers, and Ansa could also talk to some of the translational work, if any, with farmers.
Yeah, I think that's a really important point. So there's two aspects of sharing. There's also the research component. So we want that information to become to be accessible to researchers, so that you can invigorate the research community around these topics and say, somebody sitting at a university is doing this kind of work, let's work together on something. So there's two aspects of it. But then yesterday in that discussion that we were on the smallholders, remember the very first one, there was a lot of discussion about how we translate information that is accessible to all levels, so that you don't speak science to a farmer, but that you speak the language that makes sense and has value. And I think there's a gap. I think as scientists or researchers, it's not a natural progression from once you've finished your paper or your project and you've written it up and you've done your progress report and you've maybe delivered it at a symposium. How do you take it a step further? So I think there's a gap there, and we really need to think and innovate about how we can do that, because it's about language, but it's also about presentation.
Thanks very much.
I think from our side, what we've seen is that a lot of farmers are hesitant to allow researchers on their farms, because they normally say, well, students come, they do the research, and then they never hear from them again. They don't know what the outcome is. Did they find anything? Did they not find anything? So, and then when we do collections, we try to give feedback that we get from the researchers back to the farmers, and then they say, okay, but what does this mean? So there's, like Ansa said, there's still that gap. You can tell a farmer, well, we've seen this, but yeah, we don't do any recommendations based on that. But the researchers needs to to find out why that specific organism is on that farm and then relay the information back. But I think there must be some way that we can much quicker relay information back to the farmers and tell them this is what we've seen, this is what we're working on, even if it's a 3 or 4 year research project, but just keep the farmers in the loop, keep them informed on new things that's happening.
If I can just follow up on that, Maneshri, maybe that's something that we need to put at the door of the Biosecurity Hub, because this is different to something like, say for instance, you're doing yield evaluations. That takes a long time, or breeding. You know, this is biosecurity. So farmers need to understand, and the response time need to be shorter. So maybe from the Biosecurity Hub's point of view, we can think about some kind of gathering where we translate this into more speedily up-to-date data regularly. It's a suggestion.
Okay, thanks very much, Ansa. And that's certainly one of the goals of the Biosecurity Hub. Yes, we have organized ourselves and we have a system that we know works because it has demonstrated its ability. But we also have much more work to do, and I think that's part of the reason of showcasing the work that started with the Biosecurity Hub. In the future, we want to ensure that, and there's already been some training with the apps, with farmer groupings, etc., with some support in individual research projects where information goes back to the farmer in terms of services with managing pests and diseases. But in the long term, the whole system, and this is using science, validated science information, is how can we use systems, even AI, predictive models, to help farmers to diagnose on farm. So at the moment, they send the information, and somebody has to go back and help them with interpretation. But I suppose in the future, but that's a long time away. But the whole idea of building the databases is really to not only have information go back to farmers, but to provide that early warning system for the future. So I think with that, I want to thank the speakers for the time and for sharing today. I also want to thank you, the audience, for coming and listening to us. And certainly, as Ansa and Rudolf have mentioned, this is the first of many conversations. So today we talked more about plant health, but as we move towards shaping the Biosecurity Hub as a useful instrument, a national instrument that harmonizes the work that we do and also influences the priorities we should be focusing on to safeguard our biosecurity. We look forward to following conversations in the future. So with that, thank you very much. And now you can go to lunch.